Suppose that y equals f of x is a function. The difference quotient of f is, dun, 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 we're going to fill in the blank here. So y equals f of x, I'm just going to write it down, and if you've never seen it before, it's going to be like, huh? But I'll explain it. So it turns out to be f of x plus h, where h is just a number, some constant number, minus f of x all over h. And this works as long as h is not equal to 0, because we can't divide by 0. Okay, so first of all, let me just state what this formula is. It's the slope in disguise. It's the slope formula in disguise. It really is. Let me make you believe that. Let's say this is the x-axis, and this is the y-axis. Vertical axis is the y-axis. And let's say you have a graph of y equals f of x, and it looks like that. And, you know, it could keep going over here. It doesn't matter. So that's a graph of y equals f of x. And let's say you have a particular x value, say right here. Now, if you map that up to the function, so just go straight up from that x value, up to the function, and go straight over to the y-axis, we call that height value f of x. Would you agree with that statement? Yeah. So you could write that point, that dot on the graph as x comma f of x for any particular x. Would you believe that? Okay. Now let's add h. H is usually a very small amount, but I'm going to make it big enough so we can see it. So let's add h. Let's put the h, let's make it a little bit bigger than I was going to. Yeah, it'll be good if we put it right here. So let's make this value x plus h, so that this distance right here between x and x plus h is just h. Now do the same thing. Go straight up to the graph. What are the coordinates of this point? X plus h is the first coordinate. That's the input. What's the second coordinate? No, that notation doesn't mean times. It's f of x plus h, right? It's the output that goes with an input of x plus h. That's what f of x plus h means. Does that make sense? You may not know why I'm doing this yet, but does that make sense, that notation for those ordered pairs? Then you got it. Because just take the slope between those 2 points. Rise over run. So look, if you take the slope between these 2 points, the rise is the difference between the y coordinates, right? F of x plus h minus f of x. What's the run between the 2 points? The run is, you can think of it as just this distance h, or x plus h minus x, which is h. And that's exactly the difference quotient. Why the heck do we need another formula for slope? Rise over run works fine. Well, it turns out that this formula is very handy for defining something called the derivative. And if you've never heard of that, don't worry about it. You'll hear about it soon enough when you get to calculus. But the idea is, we found the slope of the line between these 2 points, right? That's the difference quotient. Now, a slope is a rate of change. And so that difference quotient, that slope between those 2 points, represents the average rate of change in the function from x to x plus h. And the idea is, as you shrink h to 0, that average rate of change gets closer and closer to a real-time rate of change called the instantaneous rate of change. So that if this function represents the distance, say, an object is from a starting point, then what this difference quotient has to do with is the average velocity. If like x is time and the y-axis represents distance, what that slope is the average velocity. The difference quotient is the average velocity of the object traveling along that curve. And so in physics and in calculus, it's a really important object, that difference quotient. Find the difference quotient for f of x equals x squared plus 5. So let's write down the difference quotient again. DQ stands for Dairy Queen and difference quotient. It's f of x plus h minus f of x all over h. So as always in this class, use the formula as a guide. It tells you what you need. It tells you need f of x plus h, doesn't it? So what does that notation mean? Symbolically, when you're dealing with the symbolism as opposed to the graph, it just means replace x. Wherever you see an x in the formula, you replace it with x plus h, right? So f of x plus h, replace the x in x squared plus 5, replace it with a set of parentheses. So parentheses squared plus 5. And then in that set of parentheses, you put in the x plus h. That's how you find f of x plus h. Does that make sense? Okay, so then the difference quotient is going to be that thing we just found minus the original function all over h. So the difference quotient is going to be x plus h, quantity squared, plus 5, minus, f of x, that's the original function, but you've got to put parentheses around the whole thing because you're subtracting the whole thing. Minus x squared plus 5. So does everybody see that's the numerator? Let me make sure that's clear. So this part is f of x plus h, and this part is f of x. So that's the numerator of the difference quotient, f of x plus h minus f of x. And then in the denominator, we just have h. Now we're going to simplify this, but is that okay? Or maybe it's not okay. Maybe that's not the right word. Does that make sense? You might not be okay with it, but does it make sense to you? That's more important. Okay. So now let's simplify it. So we're going to have to multiply out the x plus h. Do you guys remember the formula for doing that? A plus b quantity squared. I mean, you could write down x plus h times x plus h and FOIL it out, but this is faster. A plus b quantity squared is a squared plus 2ab plus b squared. In this case, x, what's acting like a? X, and what's acting like b? So you do all that in your head after you get used to that formula. And then you just look at the right-hand side of the formula, and it tells you to square the first guy, a being the first guy, b being the last guy. That formula says square the first guy. The first guy is x. What do you get? You get x squared. And then the formula says take the first guy times the second guy and double it. X times h doubled. 2xh or 2hx if you like, if you prefer. Either one. I'll go 2xh. So that's the plus 2ab, 2xh. And then it says add in the last guy squared. Plus h squared. So that's just x plus h quantity squared so far. And then what do you add in? Don't forget that 5 right there, right? And then what do you have to do with that minus? Distribute. What do you get? Minus x squared minus 5. Now I'll tell you a trick to know if you're on the right track. In the numerator, anything without a factor of h should cancel. If it doesn't, you did something wrong, for sure. Anything without any term without a factor of h should cancel. So I see just an x squared, no factor of h. There better be a minus x squared, and there is. And that's a nice trick to know because you can look for the appropriate like term. I see 2xh, that's probably okay. I see a plus h squared, that's okay. I see a plus 5, no factor of h. I fully expect there to be a minus 5 somewhere else. Okay, so what's left? 2xh plus h squared over just h, right? Now, both terms in that numerator have an h, so what can you do? Factor out the h. What's left in the numerator? In the parentheses?
2x plus h.
All divided by h. Now, because you made the operation multiplication between the h and the quantity in parentheses, it's okay to divide. And so the difference quotient is 2x plus h